Hello, my name is Admin Frank, and today I'll show you how a transistor works. Let's start with the index. First, what is doping in the way of a semiconductor? Second, how does a negative, positive, negative transistor work? Third, how does a positive, negative, positive transistor work? Fourth, how does a vacuum tube work? And for the fifth, I'll compare the vacuum tube and the transistor. So let's start with what is doping. All elements out of the fourth row from the periodical system are considered semiconductors. However, not all of them are considered as the best semiconductors for this kind of job. So, silicon and germanium are the best semiconductors to be used for the job as a transistor. Now, since semiconductors have got 4 valence electrons, they are very bad in conducting electricity, so they must be doped with other elements. So let's start with the acceptors. By positively doping a semiconductor, the whole molecular structure of that semiconductor will lose 1 valence electron, which means it is missing 1 electron. And as you probably guessed, you can also negatively dope a semiconductor. This way, the molecular structure of the semiconductor will have 1 valence electron more. And now, to make this all a little bit more graphical, the left structure is pure silicon. It has got 4 valence electrons, and electric conductivity is nearly impossible. The middle silicon structure is doped with phosphorus. This way, it is negative. It has got 1 electron more than silicon. This electron is freely movable along the structure. Now the right structure is doped with boron. Boron has got 1 electron less than silicon. This structure will do anything to get this empty electron filled. Since you now know what negative and positive doping is, the next part will be quite easy and fast. So N is negative doped and P is positive doped. Now the electricity coming into the collector, so the first negative part of the transistor, the electricity will not be able to flow out of the emitter because at the basis, the positive part of the transistor, electrons are missing. So electrons have to be pumped into the basis of the transistor. Now the positive, negative, positive transistor is completely opposite. In other words, the basis has got too many electrons. So the too many electrons from the negative part of the transistor have got to drain out of the basis to make room for fresh electrons filling up the positive part to make the electrons flow for the transistor. So this is practically a drainage system. Now I'll tell you how a vacuum tube works. So let's say that all components would be connected to a network. The warm electrons from the cathode will flow via the activated grid to the anode. However, vice versa is not possible because the electrons coming from the anode are not warmed up. But if the grid is deactivated, then electrons will not be able to pass in any direction. The distance is just far too long for the electrons, even if they're heated. Now I'd like to compare the vacuum tube with the transistor. Since the transistor uses less electricity than the vacuum tube, it is clearly more effective, and since there is nothing to warm up, it is faster to start. The vacuum tube, however, is compatible with older machines. In lessons it is easier to explain than smaller diodes. Obviously it's still got that vintage feel, and some people say you get better audio. Thank you for watching this video. I hope you now understand the transistor and vacuum tubes. Please do like this video or subscribe, it does help. Thank you.